Hello everyone and welcome to this presentation on indices of Subarray sum. In this presentation we will discuss how to find the indices of a subarray within an array where the sum of its elements equals a specified target value. The problem we are solving involves finding a contiguous subarray in an array ARR whose sum is equal to the given target value. The input consists of an array containing non-negative integers and the target sum. Our goal is to return the one-based indices of the leftmost and rightmost elements of the subarray. If no such subarray exists, we return -1. We will also review some important constraints like the array size and value ranges. Let's go over an example. Given the array containing the elements 1, 2, 3, 7 and 5 and a target sum of 12, we want to find a subarray whose sum equals 12. If we look closely, the sum of elements from indices 2 to 4 inclusive gives us 12. Therefore, the output will be 2, 4. Here's another example. Consider the array with elements 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 with a target sum of 15. If we sum the elements from indices 1 to 5, we get 15. Hence the output for this input is 1, 5. Now let's look at a case where no subarray matches the target sum. Given the array 5, 3, 4 and a target sum of 2, there is no subarray with a sum equal to 2. So the output in this case will be -1. To solve this problem efficiently, we can use a technique called the sliding window. The idea is to maintain a window of elements which allows us to compute the sum in linear time. This approach ensures we don't have to check every possible subarray, which would be inefficient for large arrays. The first step is to initialize two pointers, start and end, both starting at the beginning of the array. We also initialize a variable current sum to 0. As we iterate through the array with the end pointer, we keep adding the element at ARR end to current sum. Next, we check if the current sum exceeds the target. If it does, we move the start pointer to the right and subtract elements from current sum until it's less than or equal to the target. This process helps in shrinking the window when the sum becomes too large. Once we have a sum equal to the target, we return the one-based indices of the start and end pointers, representing the subarray that meets the criteria. If no such subarray is found, after going through the array, we return -1. Let's take a look at the code implementation. First, we declare the function find subarray sum, which takes the array ARR and the target sum target as input. We initialize start to 0 and current sum to 0. We then iterate over the array with the end pointer. At each step, we add the element ARR end to current sum. If the sum exceeds the target, we shrink the window by moving the start pointer forward and subtracting ARR start from current sum. If we find a matching sum, we return the indices. Now Let's now go through a dry run with the input array 1, 2, 3, 5, 7 and the target sum 12. Initially start is 0 and current sum is 0. As we iterate through the array, we update current sum accordingly. After iterating through the array, we see that the sum from indices 2 to 4 equals 12. Therefore, the algorithm will return the indices 2, 4. Let's discuss the time and space complexity of the algorithm. The time complexity is big of n, where n is the number of elements in the array. This is because we only traverse the array once and each element is added and removed from the current sum at most once. The space complexity is big of 1 as we are only using a constant amount of extra space. In conclusion, the sliding window technique is an efficient solution to the indexes of subarray problem. By dynamically adjusting the window, we can find the subarray with the target sum in linear time. This approach is particularly useful for large datasets as it minimizes the need for the nested loops.